Welcome to our video on the measurement of length in motion. We will explore how measurement has evolved from ancient handspans to modern concepts like the relativity of movement. We have a universal need for precision. Measurement is the hidden architecture of daily life, from tailoring clothes to planning towns. Tools like the metal rod and flexible tape serve different contextual needs for accuracy. Anatomical measurements, like the handspan, are inconsistent due to biological variance. The length of an object cannot change based on who measures it. This inconsistency highlights the need for a fixed standard. To solve global confusion, countries adopted the International System of Units, or SI units. This standardized system, using units like the millimeter, centimeter, meter, and kilometer, allows for global collaboration. Let's look at the anatomy of a 15-centimeter scale. The smallest measurable unit here is the millimeter, where 1 millimeter equals 0.1 centimeter. Accuracy relies on correctly reading these increments. Accurate measurement requires two things: proper object alignment and the correct line of sight. Your eye must be positioned directly above the object's tip to prevent viewing distortion, also known as parallax error. If the 0 point of your scale is broken, you can still find the true length. Log both the starting and ending marks, and calculate the true length by subtracting the starting reading from the ending reading. To measure curves, use a flexible material like thread or tailor's tape as a proxy. Mold it to the curve, then straighten it out, and measure its length with a standard ruler. This translates nonlinear geometry into linear data. Distance is meaningless without a starting point or a fixed reference point. Different starting points lead to different distance perceptions. If everyone uses the same reference point, their answers will align. An object is in motion when its position changes with respect to a fixed reference point over a time interval. For example, if the distance to Delhi is decreasing from 70 kilometers to 60 kilometers, the object is moving toward Delhi. The physics of rest versus motion depends on three factors: object position, reference point, and time. An object is at rest if its position does not change relative to the reference point. It is in motion if its position changes. Motion is relative. Inside a bus, you may be at rest relative to the bus itself. However, relative to a fixed building outside, your position is changing, meaning you are in motion. The observer creates the reality.